All right, y'all. So the purpose of today's lesson slash this little activity is to understand what an inverse trig function is and what the domain and range of each inverse trig function is. So before we even start anything big, just notation, inverse sine written like this and arc sine mean exactly the same thing. Same thing with inverse cosine, arc cosine, inverse tan, arc tan. So for any trig function, the input, so what goes into the trig function, like for example here, the input is an angle. So for example here, the input is 30 degrees, and here the input is 5 pi over 6. These are both angles. And the output is the point from the unit circle. So we go to 30 degrees and we see that the y value is 1/2, and that's our answer. Here we go to 5 pi over 6, cosine is the x value, and so that's negative root 3 over 2. So the output is the point from the unit circle. And if you're being really specific, what that really is just the ratio of the sides of a right triangle. Okay, that's where we got the points on the unit circle. So for an inverse trig function, so keep in mind here we're talking about a regular trig function, and then down here we're talking about an inverse trig function. And if you recall back to when we reviewed inverse functions, an inverse just flip-flops the input and the output. So here the input is the point from the unit circle, and the output is our angle. So you can see on my example here where I said inverse sine 1/2. Well, this is my point. Here I input the point, and here we output the angle. And same thing for our cosine. Here we input the point, and we output the angle. So notice all it does is just flip-flops. Input point, input angle. Here we output angle. Here we output point. Here we input point. Okay, it flip-flops it. Now, for inverse sine, cosine, or tangent to be functions, there can only be one output for each input. So for example, let's say I ask you, what is inverse sine of 1/2? And you go to your unit circle and you say, okay, well, I know sine is the y value. So here it's 1/2 at pi over 6. So it'd go, okay, output my angle, pi over 6. But then also here at 5 pi over 6, sine is 1/2. So is my answer pi over 6 or 5 pi over 6? Well, in order for inverse sine to be a function, you can only have one answer or one output. And so we have to define what inverse sine is allowed to output. And so we define it as having its answers only in this first and the negative first quadrant. So my answer is pi over 6. And so we're going to talk a little bit about how we define where the answers are going to be. So let's first start with sine. So I'm going to graph sine over here. 0, 1, 0, -1, 0, and so on. Okay, and y'all can pause the video if you want to sketch this. I'm just going to keep on going. Now notice that I could write my points, like for example, this point here is pi over 2, 1. Well, if I want to do the inverse function, all I'm doing is I'm flip-flopping. So I'm plotting the point 1, which is about here, comma pi over 2, which is there. This point would be pi comma 0, so I need to plot 0 comma pi, which is right here. And then I keep doing that with all my points, and my graph looks something like this. Okay, this is my inverse graph of the regular sine function. And remember when we talked about inverses a couple units ago, inverses flip-flop the x and the y, and when you graph them, visually they look like reflections across y equals x, and that's what we got going on here. Okay, now the problem is that this pink graph, the inverse, is not a function. Remember that a function has to pass the vertical line test. If I do a vertical line here, it's going to touch in more than one spot. Eek. And so it doesn't pass the vertical line test. That means my x's have more than one y's. It's not a function. So I need to restrict my y values so that this is a function. So what I'm going to do is I'm going to start at negative pi over 2, and I'm only going to go up to pi over 2. I'm just going to include this chunk. And if I do that, now that highlighted part passes the vertical line test, it's a function. So notice that I had that go from negative pi over 2, which on my unit circle is down here, all the way up through 0 and up to positive pi over 2. So in other words, my answers to arc sine are going to be from negative pi over 2 to positive pi over 2. They're going to be in the first quadrant or the negative first quadrant. Now I call this the negative first quadrant, not the fourth quadrant. And that's because this goes from negative pi over 2 up to positive pi over 2. It's not 3 pi over 2, it's negative pi over 2. And so these angles down here are the negative angles. So this is negative pi over 6, this is negative pi over 4, and this is negative pi over 3. Let me show you how this would look. So like these questions down here I have as examples. This is what you could see on like a homework assignment or a quiz. So inverse sine of negative 1. So remember, this input is my point, and I'm going to output an angle. So I go to my unit circle, and I look to see where sine equals negative 1. Well, it's right there. So there's my point, my output's my angle, which in this case is negative pi over 2. Remember, I'm not putting 3 pi over 2 because my answers go from negative pi over 2 to pi over 2. So it's the negative first quadrant and first quadrant. All right, inverse sine negative root 3 over 2. So I know that sine is negative square root 3 over 2 here. And so that's input point. Oops. And my output is my angle, which is that negative pi over 3. Okay, I'll do 2 more for you. Arc sine 1/2. So sine equals 1/2 here. My angle is pi over 6. That's my first quadrant. Arc sine 0. So sine equals 0 here. And that's at the angle of 0. So remember, this is my angle. This is the point. Okay, I'm going to leave these last 4 for you all to do. Okay, let's think about the same thing, but for our cosine. So I'm going to start by graphing cosine. Starts at the top, midline, bottom, midline, top. Same thing over here. Okay, and now I'm going to do my inverse function. So my inverse function flip-flops the x's and y's. So this point here is pi over 2 comma 0. I flip-flop the x and y, and I get 0 comma pi over 2, which is this point. And I do the same thing for this point here, which is 0, comma 1. I'm going to plot 1, comma 0, which is about here. And then I just keep on going with all those points in the same way. Okay, so this is my inverse function for cosine, my inverse graph. It's not a function. And just to verify, this is a reflection across y equals x, which is what we want because you know that inverse functions reflect across y equals x. Now, I need to restrict my cosine inverse so that it's a function. Right now, it's not a function. If I did the vertical line test on this pink graph, it would not pass it, which means that the x's have more than one y's, so it's not a function. So I'm going to restrict this to go from 0 to pi, and the reason I do that is because on this little chunk here, it would pass the vertical line test. So if I go back to my unit circle, I'm going to think, okay, 0 to pi. That's my first and my second quadrant. So my answers to our cosine function problems are going to be in the first and the second quadrant. So I'll do a couple examples for you here also. Inverse cosine negative 1. Okay, input point, output angle. So in the first and the second quadrant, I want to look to see where cosine equals negative 1, and that's right here. So my answer would be pi. Okay, inverse cosine negative root 3 over 2. So I look for where cosine is negative root 3 over 2 in these two quadrants, and that's at 5 pi over 6. So that's my answer. Input the point, output your angle. Okay, arc cosine 1/2. Cosine equals 1/2 right here at pi over 3. And so that's my answer. Inverse cosine 0. So in the first and the second quadrants, cosine equals 0 here. And that would be pi over 2. So I'm going to leave these last four for you all to do. Okay, let's talk about tangent. So tangent has its asymptotes at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. And remember, this is right side up, left side down. Right side up, left side down. And so on. Now this one gets a little bit kind of messy when you graph the inverse, but wherever I had vertical asymptotes, I'm just going to have horizontal asymptotes when I flip-flop them. So I'll have my asymptotes at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. And now my function, or my graph, will look like this. Oops, this is my bad. I just flip-flopped these. Should go like this. Okay. All right. Now again, the pink graph is not going to pass the vertical line test. So I need to restrict its range so that it does pass it. So what I'm going to do is I'm just going to keep this first little chunk right here that passes through the origin, and that would pass the vertical line test. So notice that that goes from negative pi over 2 to positive pi over 2. So this is tangent. Arctan is just like arcsine. It goes from negative pi over 2 down here up to pi over 2 here. So again, we're going to use the first quadrant and the negative first quadrant. And I call it the negative first quadrant, not the fourth quadrant, because we're going from negative pi over 2 up to 0. So this we would call negative pi over 6, negative pi over 4, and negative pi over 3. So I'll do a couple examples for you. All right, inverse tan of negative 1. So again, same as before, this is input point, output angle. So I want to know where tangent equals negative 1. Well, that's going to happen right here because the y and the x are the same thing. Tangent's y divided by x, so I would get negative 1 there. Negative root 2 over 2 divided by root 2 over 2 is negative 1. And so that angle is negative pi over 4. Okay, inverse tan square root 3. So I know it's going to be positive. I'm pretty sure it's either here or here. I'm going to check pi over 3. Remember, tangent's y divided by x, so I'm going to do square root 3 over 2, the y, divided by 1/2, which is the x. Multiply by the reciprocal, these cancel, and I do get root 3. So at this angle, pi over 3, tangent is root 3. So remember, input point, output angle. All right, let's try this one. Arctan 1 over root 3. Well, that's probably going to be in the opposite spot, probably at pi over 6, but let's double check. So y divided by x there would be 1/2 divided by square root 3 over 2. So 1/2 times the reciprocal, 2 over root 3, cancel, cancel. We get 1 over root 3, which is what we want. And that was at pi over 6. Okay, oh, I have inverse tan of 0 twice. Just cross that one off. All right, inverse tan 0. Well, that's going to happen right here at 0 because there it's y divided by x. 0 divided by 1 is 0. So input point, output angle. All right, I'm going to leave these last two for you all to do. So just kind of quick summary. The whole point was to figure out where your answers were for arc sine, arc cosine, and arctan. And so for arc sine and arc tangent, your answers are in the first and the negative first quadrants. And then for arc cosine,